Our final video in this section is going to be about DevOps and CI/CD. So we have already covered the internet gateway in the last video. So what exactly is CI/CD? The name suggests it is continuous integration and delivery. So if you look at this picture, you can see the happy developer that we are. We will complete the functionality and then push our code to the repository, and then the from the repository, I mean our source code, either a GitHub or any the repository that you know out there. And then once the code is pushed into the repository, a build server will take that particular code and build, that means our jar file or war file in the case of Java applications. And then the build server, the artifact that was created by the build server, will be deployed to our production server. This is the case, and these things happens automatically without any human intervention. That is the beauty of CI/CD. So previously, if you haven't gone into any serious product development, I mean, or any serious application development yet, but what we used to do before, we used to complete our functionality in a development environment, means our local system, local servers, and we used to deploy our functionality or the code into the local Tomcat server to see whether the code is working fine. But then what we had to do, we had to raise a ticket to the department where the system administrators worked, and based on the ticket they will provide a test environment, means they will provision a server with a server system, a hardware with the required softwares as specified in the ticket by the developer. And then we had to wait for the system to be provisioned to test it. And then once we test it and the quality analyst give a go, then again we had to raise a ticket to the same system administrators to get a production server. So either whether it was the cloud environment or it was managed servers, we had to go through a lot of red tape or bureaucracy to get our job done. And the job done was to make our functionality into production. But now, because of CI/CD, a lot of these bureaucratic intermediaries can be eliminated. That's why I always tell that because of CI/CD, a lot of guys are going to or have already lost their job, because there is the little human intervention required in these circumstances when we use CI/CD. So our discussion is how we are going to have this continuous integration and delivery in Amazon. Of course, Amazon is not the just one cloud provider. There are Azure, and there is the Google Cloud, and there is the Pivotal Cloud Foundry. I mean, many cloud service providers are out there. Our discussion is limited to Amazon Web Service. So what we are going to use? We are going to use what is known as a cloud commit, which is equivalent to the Git repository that will take care of our code repository here. And of course, we need to have some credentials or the IAM policies to be applied for us to commit to the code repository, and that will be taken care of the code repository in the case of Amazon. Then comes code build, which is another service to build the application, takes the code from the code repository and give the corresponding artifact. In the case of a Spring Boot application, it will be a jar file. So that's what code build does for us. And then the last part, of course, there is a code deploy service available, But in our case, we are going to use what is known as an elastic beanstalk. What is a elastic beanstalk is, if you remember, till now, we have been provisioning the EC2 instances ourselves. We made sure that these EC2 instances were secured properly by the security group, as well as the network access control list, all these stuff. But the same goes with the S3 or RDS or whatever the services that we covered in the last couple of videos. But here we are going to talk about a new service called the Elastic Beanstalk. So what this Elastic Beanstalk does is that it takes these trouble out of us. Means we don't need to provision any instances. These instances will be provisioned by a beanstalk. So we are going to see how we are going to use a beanstalk. But in our case, it will be this beanstalk that will be acting as a deployment server. So once the code commit, we commit our code to the repository, the code build will build the artifact out of the code from the code repository, and then the build server will delegate the responsibility of deploying our application into the EC2 instances, and that responsibility will be taken care of by the Elastic Beanstalk. So the whole thing is a process. I mean, the developer will commit the code, the build server will build the artifact, and the artifact will be deployed to the deployment server, in our case an EC2 instance. But there has to be some manager who should manage the whole process. For this, we use what is known as a code pipeline. So the code pipeline will be the guy or the service responsible for managing the whole flow. The whole process of committing up to the delivery, I mean, into production, is what is known as a continuous integration and continuous delivery. Why the name came here? Because as I told you previously, we had to wait for a lot of bureaucratic hurdles to be jumped to get to the production. So now we don't need to. So once we have the code repository, the build server will make sure it not only just build the artifact, it also will test our use cases, the unit test that we have completed, and if there are any errors, then it won't proceed. It will give the corresponding mail to the development team that these are the build errors that have happened, so that it won't go beyond the build server. So only if the build server is successfully able to pass the unit test or execute the unit tests, and then it will give the responsibility to the Elastic Beanstalk to deploy it. So it is a continuous process. So previously, what we used to do was it would take 3 to 6 months to make any changes to the functionality. But now, because we had to go through a lot of bureaucracy, but now, because of continuous integration and delivery, once the functionality is complete, the developer only needs to commit. Of course, whatever the code here, the code will contain not only the functionality but also the unit test that will confirm to the functionality. So that will be in the code repository. The build server will do the rest of the job, and the build server will make sure that it won't go to production if there are any unit test errors. So we don't need to wait for any bureaucratic red tape. We don't want to communicate. We don't want to raise a ticket to the system administrators to provision the server. All these things are happening automatically behind the scenes. And it is the code pipeline service that gets the job done for us automatically. This is what we call it as a CI/CD. Whatever the service that we just talked about, these are the services that belongs to Amazon, or Amazon gave these capabilities to the developer to create a code pipeline, to create a code commit repository, to create a code build, and an Elastic Beanstalk to get the job done. But then there are many other tools existing out there. So this leads us to the discussion to the what is known as a DevOps. What we just saw in the previous slide was DevOps. So, what exactly is DevOps? The definition says that it is a set of practices And what are these practices intended for? To reduce the time between committing a change to the code repository and that code available as a production or a production instance for others to use. That what exactly is DevOps is all about. So instead of we waiting for a long time to get the testing done, to provision a particular server and to deploy the code, all these things are happening automatically. This practice of continuous integration and continuous delivery, we call it as a DevOps. And when somebody talks about DevOps, they also mean that there are a lot of tools that we can use to make our CI/CD pipeline or the DevOps thing work. You can see in this picture, it is very difficult to see what exactly this picture means. For example, you can see here for analytics, there are many different colors. So I copied it from one of the websites out there. So before we going there, just remember this is CI/CD and DevOps for you. So let us go to the website and see it a little more clearly what exactly we mean or I mean by that particular picture. So I have already saved it somewhere, hopefully in microservices. Yeah, there is what is known as a periodic table of DevOps tools. So this is available in the digital.ai and the periodic table of DevOps tools. If you go down a little bit, you can see this is the periodic table I copied the picture from. And you can see, just point your mouse to over the AI tools. You can see what are the AI tools. These are being highlighted. See here, these are the AI tools. I mean, Instana, Datadog, Splunk, App Dynamics, Dynatrace, Neuralink, Grafana, and Elastic ELK stack. So, know what exactly ELK? Elasticsearch, log stack, log. Sorry, Elasticsearch, Logstash, and Kibana. This will be we will be using or we will be learning about this when we talk about microservices. And then Grapha is also another tool for graphical representation of our data. So these are all five for analytics or optics. So see what exactly is happening with the data. And then next is package management. These are some of the package management available. JFrog, then Sonatype, Nexus, then Docker Hub. We will be talking about Docker, Yarn, which is another build tool, NuGet, and NPM. You know, this is NPM. We already learned about this in Angular, which is a node package manager. These are for package management. And then what exactly is the cloud? Of course, you can see AWS, Azure, Google Cloud, IBM Cloud, and OpenStack. These are some of the cloud providers we have. And for collaboration, what we use Slack or microservices team. You will be using any of these for collaboration. Stack Overflow and Mattermost. I have used Slack, Microsoft Teams if you are, and Atlassian. There are two things called Atlassian Confluence and Atlassian Jira for collaboration. I mean, what is collaboration here means they collaborating between the different teams online and offshore. And then continuous automation. You can see here, I'm not going to go into each and everything. You can see some of Chef, Puppet, Salt, HashiCorp, Vagrant. There are a lot of tools for each, and the container. You can see there is a Docker, and there is a Red Hat OpenShift, Kubernetes, the Amazon EKS that we will be talking about, the Azure AKS. These are all Kubernetes implementation, and the GKE. I'm more proficient with the GKE than the Amazon EKS, but then we have to cover that too. So these are some of the tools that is existing out there. So you can go to continuous integration. You can see Jenkins, Azure, and the GLC. What exactly for GitLab, Travis CI, Circle CI, Maven. Uh, no Amazon. Yeah, see here, Amazon code build that is being given here, and then deployment. So there are a lot of. So you can see here in the deployment there is a code deploy, but we are not using the code deploy right now. We are actually in place of code deploy. We are going to use what is known as an Amazon Beanstalk. So then you can see security. You will see the, I think, Spring Security somewhere here, Sonar Cube. We have already talked about the Sonar Cube. So these are some of the tools, existing tools available out there for DevOps. So what does DevOps means? Using some tools to get rid of red hat or red tape, sorry, not red hat, to get rid of any red tape, bureaucratic hurdles that prevent us from delivering the functionality as quickly as possible to the client. So these are some of the tools that we usually use. Most of these are open source stuff, and you can see in the testing, if you look at the testing, you can see there are a lot of testing, and the JUnit is one of the testing. Of course, you may have already heard of JMeter. There is Cucumber. These are some of the non-terms. So I'm just speaking what are the non-terms to me. Selenium for end-to-end testing and for UI testing and all the stuff. We have already talked about Angular testing in that case. And source code, you can see Git, GitHub, GitLab, and Subversion. These are some of the. So in total, we now know most, if not all, of the different tools existing out there for DevOps. So again, going back to our discussion, what we are going to use will be this stack. I mean, we will be using, instead of GitHub, we will be using code commit. For building, we will be using a code build. You can use a Jenkins also for code build. But here we are discussing about AWS, so we will be using code build. And then we will be using the Elastic Beanstalk. There is also a code deploy, but instead of code deploy, which is a little bit more involved. That's why, and even you don't need to know this, you can see that there is already a video for a CI/CD given by some employee of a CTS, but he is not employing any of these things. He is taking an easy route to get the job done. I mean, he's just playing with a simple Spring Boot application. I'm a Spring application where he's changing only the UI and giving you. So I thought of giving you a little bit more. So the REST API to do application that we developed during our REST API discussion, we will be deploying that to do REST API. Yeah, commit into the code, then build it, and then use Elastic Beanstalk to deploy it into the application server. That will be our discussion. So let us go into the Amazon and get the job done. So let us complete that from the next video. So bye for now.